Okay, to solve this particular question from the Advanced Algebra 2 homework, the directions were to write a polynomial function with the given zeros. Now, you have to remember that imaginary zeros have to come in pairs, again, because imaginary zeros are derived from, or derived by, found by taking the square root of a negative number. And anytime we're using square roots, either to solve or in the quadratic formula, it's always plus or minus that square root. So, if you look here in x, one of the zeros is x equals 2 plus 7i, then x equals 2 minus 7i must also be a 0, and if x equals negative 3 plus 4i is a 0, negative 3 minus 4i must also be a 0. Now, if we're going to use these zeros to write a polynomial function, we have to take these zeros and turn them into factors. Now, remember, factors are equal to 0, so we're going to move everything to one side. In this case, this factor would become x minus 2 minus 7i. This factor would become x minus 2 plus 7i. And what we're going to do is we're going to multiply these together. Let's see, we're also going to multiply together these factors. This factor would be x plus 3 minus 4i and x plus 3 plus 4i. Now, we could go ahead and distribute this trinomial over this trinomial and then this one over this one. Either way, I would recommend multiplying these together, and then multiplying their products. The reason being just because the i's are going to cancel out and things are going to cancel out in a way that's going to make this problem a little bit easier. Instead of distributing the trinomial over the trinomial, what I'm going to do is use parentheses to group the first two terms here and the first two terms here, turning these trinomials into binomials. Now what we've done is we've taken these two terms, grouped them. We're now viewing this as one binomial term. We have one binomial term and one monomial term, making this whole thing now viewing it as a binomial. Same thing here. Same thing here and here. And the reason we did this is now we've turned these into what we call conjugates. Conjugates are binomials whose first terms are the same. We have here x minus 2 and x minus 2, and whose second terms are opposites. And the reason this is helpful is because when you FOIL conjugates, the O and the I in the FOIL will always mathematically just cancel itself out. Now, what I'm saying here is that FOIL, we only need to worry about the big F and L. Now, within that first, we do have another FOIL. Now, within that FOIL, we are multiplying x minus 2 times x minus 2. Those aren't conjugates, so O and I won't cancel out there, so we'll need to carry out all four steps here. So we'll do that first. X times x is x squared. X times a negative 2, negative 2x. Negative 2 times x, negative 2x, and negative 2 times 2 is plus 4. L times L would be a negative 49i squared. Okay, so here we have the first F, which is a FOIL. And then last, again, O and I canceled out because they were conjugates. Combine like terms and simplify. This here becomes a positive 49 because I squared is equivalent to negative 1, and negative 49 times negative 1 is positive 49. This becomes a negative 4x plus 4, which simplifies to x squared minus 4x plus 53. Okay? So from these trinomials, which we turned into binomials, we have this quadratic function, x squared minus 4x plus 53. We're going to do the same thing here. Again, they are conjugates. But within that first f, we have another FOIL. They're not conjugates. We have x squared plus 3x plus 3x plus 9. L times L, we have a negative 16i squared. Again, this is going to become positive 16. This is going to become a positive 6x and a positive 9. X squared plus, 6x plus 25. So now what we have is we have this quadratic function and this one. We have got to multiply these together. Now in this case, we don't have any special tricks. We just have to distribute one trinomial over the other one. So that is what we'll do. So we'll take x squared times x squared, giving us x to the 4th. X squared times 6x, giving us 6x cubed. X squared times 25, giving us 25x squared. We will take the negative 4x times x squared, which would be a negative 4x cubed. Negative 4x times 6x, giving us a negative 24x squared. And a negative 4x times 25, giving us a negative 100x. Last but not least, we have x squared times x. that's completely wrong. We have 53 times x squared, which is 53x squared. 53 times 6x, which would be, I believe, 318x. And then we have 53 times 25. Let's see, divide 53, 4, 12, 13, 1,325, I believe. And from there, we're going to combine like terms. We combine like terms, x to the fourth, no other x to the fourth, so we have x to the fourth, which makes sense. Fourth degree polynomial, for a total of 4 zeros. 6x cubed minus 4x cubed is 2x cubed. That's it. So plus 2x cubed, taking care of this, taking care of these. 25x squared minus 24x squared is x squared, plus 53x squared would be 54x squared. Negative 100x plus 318x would be a positive 218x plus 1,325. And that is a polynomial function with those four given 0.